This is problem 1A, and 1A is asking you the factor of the information given, which is the population from 1970 and 1980, and these are the population by millions.
Okay, so then you take 226 million and divide it by 203 million, and that gives you the factor of the population of growth, and the answer is 1.1133005.
Problem 1B. It's a graph that shows population versus years throughout the years of 1970 to 2010.
In 1970, there were 203 million people. In 1980, there were 226 million people. In 1990, there were 251 million people. In 2000, there were 280 million, and in 2010, there were 311 million.
This is problem 1C, and for 1C you have to put all the population and the years in a table. And the population is Fx and the year is X. But instead of putting 1970, you have to put in these values of 0, 1, 2, 3, and 4 into this equation. And these are the population by millions. And you have to put these populations as A.
So when you plug in the 0 for the x, then b to the 0th power becomes 1. So it goes away. So you're left with 203 equals a. So you plug in the factor 1.1133005, and you put it to the 1/10th power, and you get this answer, the particular equation expressing population.
Okay, so we're doing problem 1D, where we need to find out the population for 2010, and we do that by using this equation y equals a times b to the x, where y is the population, a is the original population that was given, b is the base, and x is the years.
Alright, so 23 is the population we started with, and then 1.11 is the rate of the growth, and 4 is the year, is the fourth number on the x-axis. So when we multiply everything, we got 311.85.
Okay, this is problem 1E. The problem is asking for us to find out the year in which the population is closest to 400 million. We do that by plugging in the value to this equation. Because we already know the value for 2010, we start by plugging in 2020, and the value for that is 5. So the answer is 347.183 million. And that's still too low. So then we try using 2030, which the value for that is 6. So you get 386.519 million. And that's still too low. So then you try 7, and it becomes 430.312 million, and that's too high.
So we have to find a number between 386 and 430 to get 400. So we started by plugging in decimal points of 6. So we plugged in 6.1 and we got 390.69. That was still too low, so we raised it to the 6.2 power to get 394.905. That was still too low, so we raised it to the 6.3 power, and we got 399.167. We wanted to find another number that might have been closer, so we raised it to the 6.4 power, and we got 403.474. But the previous one was closer to 400, so the answer is the year 2033.